friends, welcome you all to Think Maths. We are in class 11 Maths, chapter 1, sets. In this session, we are going to discuss about the example problem 6, 7 and 8. So example 6, state which of the following sets are finite or infinite. So as per the definition, finite means the elements in the set should be countable. Infinite means the elements in the set are uncountable. Okay. So now let us check whether which set is countable or uncountable. Now the first problem, set of all x such that x belongs to n and x minus 1 into x minus 2 equal to 0. So n is a natural number system. So we have to find out the solution for this equation and check what are the numbers belongs to natural number system. So here what is given? X minus 1 into x minus 2 equal to 0. So that means x minus 1 will be equal to 0 and x minus 2 will be equal to 0. If x minus 1 is equal to 0, then x will be equal to minus 1 will become plus 1. X will be equal to x minus 2 is equal to 0, then minus 2 will become plus 2 when we change the sign. So this 1 comma 2 belongs to natural number system. So this both the solutions are satisfying the natural number system. Therefore, the elements in this set are 1 comma 2. So there are two elements in this set. So which is countable. That means the first problem is the finite set. Okay. Next one. Second one. Set of all x such that x belongs to n, natural number system, and x square equal to 4. So we have to find out the solution for x square equal to 4. X square equal to 4. So x square will be equal to 4 can be written as 2 square. Now take square root on both sides. So square root and power 2 gets cancelled. So that will be x will be equal to plus or minus 2. Now here x is a natural number. In natural number we don't have negative values. So here minus 2 does not belongs to n. Only 2 belongs to n. So the only element in the set is 2. Okay. So we all know if only one element is in the set, it is called singleton set. So only one element, so it is finite set. Next one, third one, set of all x such that x belongs to natural number and 2x minus 1 equal to 0. So find out the solution for 2x minus 1 equal to 0. So 2x will be equal to minus 1 will become plus 1. So x will be equal to 1. 2 is in product, so it will come to division. So this is of the form p by q, that is rational number system. Here x belongs to natural number system. So 1 by 2 does not belongs to the natural number system. That is, there is only one solution, but that solution doesn't satisfy the natural number system. So there is no solution. That means this is a null set. We don't have any elements in the set. We can write this. That is, start with the curly bracket and close the curly bracket. No elements, or we can write it as 5. So this is the denotation for null set. So this is a null set. Example of a null set. Null set means how many elements? 0 elements. So it is also countable. So it is finite set. Okay. Next, fourth one. Set of all x such that x belongs to n and x is prime. So x x is a natural number and that natural number should be a prime number. So what are the numbers it takes? Prime number starts with 2, 3, 5, 7, 11, etc. There is no end here because natural number is the counting numbers. So from the counting numbers, we have to find out the prime number. So it goes on like this. There is no end to this. So we cannot count the prime natural numbers. So it is an infinite set. Example of infinite set. In the same way, fifth problem, set of all x such that x belongs to n and x is odd. So x is a natural number and that natural number should be odd. What are the odd natural numbers? 1, 3, 5, 7, 9, 11, etc. It goes on like this. There is no n. So we cannot count how many numbers are there. So it is infinite set. So now you are clear with finite and infinite set. So moving on to the next example in the next page. Example 7. Find the pairs of equal sets if any, give reasons. Equal sets means we will write as A equal to B. When will A will be equal to the set B? If number of elements in A. Number of elements in A should be equal to number of elements in B, as well as elements in A should be same as elements in B. See, this is the condition for equal sets. Now here there are 5 sets. We have to find out which pairs are equal. Now let us take here A is nothing but set 0. So that is the only element in A is 0. 0 belongs to A. Okay. Now it is B. What is B? Set of all x such that x is greater than 15 and x is less than 5. Can you find a number which is less than 5 and greater than 15? No. Less than 5 means it will be less than 15. Greater than 15 means it will not be less than 5. So there is no number which satisfies this condition. So B is nothing but the null set. So B is equal to null set, or we can say 5. Okay. Nothing belongs to B. So next C. C is equal to set of all x such that x minus 5 equal to 0. That means here x minus 5 is equal to 0 means x will be equal to minus 5 will become plus 5. So the only solution is 5. There is no condition whether it is natural number or integer. Just we have to find out the value of x. So here 5 belongs to C. That means C is equal to the only element 5. It is an example of singleton set. So C is equal to 5. Okay. Next you take D. D is equal to set of all x such that x square equal to 25. So what are the values for x? X square equal to 25. So x will be equal to, what is the answer? So we can write x square equal to 25 can be written as 5 square. So taking square root on both sides, we will get x is equal to plus or minus 5. So that means 5 belongs to B and minus 5 belongs to B. So that means B takes the values, elements, minus 5 comma plus 5. Okay. Now take E. E is equal to set of all x such that x is an integral positive root of the equation x square minus 2x minus 15 equal to 0. Now here we have to solve this equation. We will get 2 solutions. So from the 2 solutions, we have to take only the positive root. So x square minus 2x minus 15 equal to 0. So this can be done in 2 methods. First I am going to do as, this is the coefficient. 1 is the coefficient of x square. So 1 can be written as 1 into 1. Put 1x here. Next 15. 15 can be written as 3 into 5. Put the magic cross. Now 1x into 3 is 3x. 1x into 5 is 5x. Now we need minus 2x. How will you get minus 2x? Minus 5x plus 3x is minus 2x. So minus 5 comes here. So put that minus here and plus here. So it is x plus 3 into x minus 5. Another way, usual way, that is we will be factorizing. How we will factorize? We will write this as minus 5x plus 3x minus 15 equal to 0. So taking the x as common, x minus 5, here 3 as common, x minus 5 equal to 0. So we will get the same x plus 3 into x minus 5. X plus 3 into x minus 5 equal to 0. Now what are the solutions? X plus 3 is equal to 0. That means x will be equal to plus 3 will become minus 3 if we change the side. X minus 5 is equal to 0. Then x will be equal to minus 5 will become plus 5. Now we need only positive root. So which is positive? 5 is the only positive root. So 5 belongs to E. That means E has the set 5. Now A is equal to 0. That is A has the element 0. B is the null set. C has the only element 5. B has the elements minus 5 and plus 5. E has the element only 5. So here 0. 0 is not in any of the sets. So we cannot take A. B is the null set. There is no set which is null set. So we cannot take B. Now C. C is equal to set of all 5. So this 5 is present in B as well as in E. But in B we have another extra element minus 5. This minus 5 is not in C. That is minus 5 does not belongs to C. Now we cannot take this element. This is D. I'm sorry, not B. This is D. So minus 5 does not belongs to C. So we cannot take this D. Now take C and E. The only element in both C and E is 5. So C equal to E, which is 5. Set of all 5. Okay children. So the pair of equal sets are C and E. I hope you can understand this example. So moving on to the last example in the next page. Example 8. Which of the following pairs of sets are equal? Justify your answer. So here first problem x. X is nothing but set of letters in alloy and B is the set of letters in loyal. Now let us frame the set x in roster form. What are the letters here in alloy? We have A. Next letter is L. Next letter is also L. It is already written, so leave it. Next letter is O. Next is Y. So these are the letters in the set. Letters are alloy. Next take B. What are the letters? L, O, Y, A. Another L is there which is already written. Okay. So in both we have 4 elements. So number of elements is same. Whether the elements are same, A is present, A is here. L is present, L is here. O is present and it is also here. And Y is also in B. So all 4 elements are same. The order can be changed but the element should be same. So we can write X equal to B. That means X and B are equal sets. This is the solution. So next one, second question. A is equal to set of all n such that n belongs to z. Z means integers. And n square less than or equal to 4. And B is equal to set of all x such that x belongs to R. R means real number system. And x square minus 3x plus 2 is equal to 0. Now first let us find out the elements in set A. So in set A we have integers. So what are the integers? We can take the integers as minus 3, n is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3. Now let us check whether n square. What is n square? Minus 3 square is 9. Is it less than or equal to 4? No, it is not less than or equal to 4. So n is equal to minus 3 doesn't come under A. Now n is equal to minus 2. What is n square? Minus 2 square. Minus square is positive. So 2 square is 4. Yes, it is less than or equal to 4. So it satisfies this condition. Now n square for minus 1. Minus 1 square is 1. It is less than or equal to 4. It satisfies. n is equal to 0 means n square is equal to 0. It is also less than or equal to 4. Next, n is equal to 1, n square equal to 1, less than or equal to 4. N is equal to 2, n square equal to 4, less than or equal to 4. So, all these three satisfies. Next, n is equal to 3. So, n square will be equal to 9. So, it is not less than or equal to 4. So, it doesn't come. So, the only thing is minus 2, minus 1, 0, 1, 2 are present in A. So, A takes the values minus 2, minus 1, 0, 1, 2. So these are the elements in the set A. Now we have to find out the elements in set B. So in B, X is nothing but real number system and it should satisfies this quadratic equation. Now let us solve the quadratic equation. X square minus 3x plus 2. So it is the coefficient 1. So 1 into 1. Put an x here. 2 can be written as 1 into 2. So put an magic cross. 1x into x is x. 1x into 2 is 2x. So we need minus 3x. So both should be negative. That means put the negative sign here. So this can be written as x minus 1 into x minus 2 equal to 0. So x minus 1 is equal to 0. X minus 2 is equal to 0. That means x will be equal to minus 1 will become plus 1 when we change the sign. Minus 2 will become plus 2 when we change the sign. So B 1 and 2 are both real numbers. So B has the elements 1, 2. Now if we check A and B, now if you check in A, we have 5 elements. In B, we have 2 elements. So only here 1, 2 is present. Okay. The elements minus 2 does not belongs to B. Minus 1 does not belongs to B. 0 does not belongs to B. So all the elements should be present in both the sets. So if it is not so, then A and B are not equal sets. So A and B are not equal sets. Okay, so this is the solution for this problem. Okay, so with this, example problems are over. So in the next video, we will discuss about the exercise 1.2. So if you are able to follow my videos, just show your support by subscribing to this channel and share among your friends and put a like to my channel. Okay, thank you.